Nice and early. Bright and early. Well, the opposite of bright and early. I don't know what the time is. Hello, today we're going to Solihull to go and pick up another synthesizer. So anyway, it's 6:30. I said I'd be there around 10, so we best get going.
So yes, we're off to Solihull, which is about 200 miles away, so you'll see the sun is slowly coming up as we're driving along Thanet Parkway. I decided to go along the bottom of London to avoid Dartford Crossing because that's a tedious thing, especially in rush hour, but we had problems.
Got a bit of a problem today. It is indicative, I think, of an electrical issue. I've spent the time trying to figure out what it might be. So if you notice there, it was stuttering. It's been doing that since about half an hour, 45 minutes in. Anyway, onwards and upwards, I say. Onwards and upwards. Oh, shucks. We're about an hour and a half away, so let's go cracking.
So I continued relatively unfazed along the road, nursing the vehicle because it kept on coming and going, this problem. It was driving me up the wall. I couldn't figure out whether it was fuel or it was ignition. There was one instance when I got to a roundabout and it decided to just stop completely.
Daddy's here and it's broken down. If it is a battery problem, it'll just come to life.
Luckily, this was the only time that it caused the car to completely stop, but it was a problem that was plaguing the whole journey. It was not bad enough to stop and hand in the towel, but it was still very annoying, and I was trying to figure out the whole way, but this is not the scope of this video. This is for another video that I've made on the Look Mum No Engine channel about the journey and the road trip and the problems, because it's not about the journey, this video, it's about the destination. So we got to Solihull and had a chat with Bill.
Here we are with Bill. And where are we? In Solihull?
We're in Solihull, yeah, just south of Birmingham.
Sunny Solihull. And yeah, I'm here to talk about a DIY synthesizer you built back in...
That's right, yeah. I mean, back in the day, when Charles Blakey was still alive running Digisound, I bought a lot of his stuff.
Mm-hmm.
I actually had a 15 module setup that I sold for just over 100 quid.
Oh, okay.
Back then, which I really was upset about.
Oh, wow. Yeah.
So I built this out of Digisound bits.
Oh, so it's Digisound?
Inside it's got a Digisound digital controller.
Mm-hmm.
It's got a Digisound voltage controlled oscillator, digital oscillator there. And it's got a Digisound voice card, which is like a card that size with two envelopes, two oscillators, all Curtis chips.
Mm.
And it's my take on a Mini Moog. But it's somewhat large and it's somewhat
big.
heavy.
Oh, is that the bits for the digital controller?
Yeah, that basically monitors the digital. It's a digital scanning keyboard,
yeah,
which goes into a DA converter in there.
Mm-hmm.
So that is actually when you turn it on.
Magic smoke time.
Providing it doesn't go up in smoke. When you turn it on. It gives you...
Very cool. Oh, you can hear the spring reverb. Is there a spring reverb?
There's a spring reverb in there.
Ah, very cool.
So as I said, inside you've got Digisound keyboard controller, DA converter.
Mm-hmm.
These were from a Korg years ago.
Yeah.
And all completely Curtis chips. And there's a Maplin spring reverb tucked away inside.
Oh, okay. Is that from the...
It's a Maplin project from years and years ago.
Is it part of the... oh, man, the name of it's completely disappeared. The Maplin synth.
Yeah, it was possibly in the
Maybe.
4600, the big one.
Yeah,
You've got one of those, haven't you?
Yeah, but the name's completely disappeared. So from what I understand of the voltage-controlled digital oscillator, the Wavetable oscillator, that it's got an EEPROM in it, correct?
It's got an EEPROM, 32 tables, so you've got 4 banks of 8 waves.
Do you remember how you programmed that, or did you get it pre-programmed?
It was pre-programmed.
Yeah.
From Digisound. So I mean, these are all. It's just basically
That's a nice control surface for it,
related
isn't it?
on a sort of like a mini Moog, basically.
It's, yeah, Mini Moog meets Oscar
Yeah.
in a weird way. Like, from what I understand, there's also the EEPROM. You could put any EEPROM in it, and it will read the data just like.
Yeah, I mean,
so
all the EEPROM basically is a set of wavetables.
Yeah, so it can be a wave. They're
So-
very cool.
And inside there's a massive wiring, obviously.
Yeah.
Tucked along here are the logic cards, which basically drive the LEDs on the various switches. So you put lots of modulation and things in, but it obviously being analog and Curtis, it needs to warm up and it needs to be kept in tune.
Of course.
So when you take the back off there,
Yeah.
there's a whole load of controls. It's all marked with the voltage per octaves and things like that in it.
Oh, I
But,
see. Oh, yeah.
But to be honest, I've got into the stage now when I bought a lot of Behringer stuff and a lot of Frequency Central
Yes.
stuff, and this guy just doesn't get used.
So this is the construction.
Yeah, construction documentation. So you've actually got in here the original Digisound booklet.
Oh, that's amazing. Yeah.
That's from Charles Bakey,
Yeah.
and bits and pieces of my circuitry. So that's basically the voice card blown up, and that sits on a board that I made with all the interfacing circuitry and LFOs and things like that. So it sits on there with a long connector there. When you take it open, when you open it up, you'll see all that.
Oh, yeah. So we're listening to the digital. Yeah, we are. Ah. That sounds interesting. Huh? That's cool.
Variable pattern.
Hey, it works. That's very cool.
So you've got cross modulation and all sorts of other bits and pieces.
Yeah, it sounded like cross modulation. So it sounds like you put a lot of thought into the patching.
Took a long time to design it. I actually had 4 Digisound voice cards and their AlphaDAP controller, which I built into a massive beast. This was my take on a Jupiter, but it was heavy and there was no automatic tuning of the voice cards. And I actually sold it to Birmingham University then, and they couldn't make it work.
The
But
Fortran.
so I kept one voice card back,
Yeah.
which was the basis here, because I said on a board that sort of size, you've got 2 oscillators, 2 envelopes, VCAs, cross modulation VCAs, and the 3372 chip, which has got VCAs and a filter in.
Oh, okay.
So it's all Curtis basically. It went wrong some time ago, and I couldn't work out why there was no sound. And then I realised that when I put a scope on it, that everything was running at supersonic speed, and in fact the 15-volt feed, all of the controls are 15-volt fed. The wire had come off it. So
so it was all.
so everything was it was that the earth had come off. So everything was running at 15 volts, which meant that the VCDO was supersonic. February 84.
February 1984. So you.
It was back in, I built an analog sequencer, and I did this little design, if I can find it, for, there we go. There you go.
Oh yeah.
That was the
So that was a sequence that you've made.
that sequence I made.
That's cool.
And the idea of that was you got six presets there.
Six presets of clock speeds.
Top speed. So basically, it was a 3340 Curtis chip with just preset voltages that you could actually run off.
That's very cool. That's
They
awesome.
actually published it and actually paid me 125 quid.
Oh, that's amazing.
Made
They're the
them-
iron-on things, aren't
No,
they?
stick on.
Stick on? You don't even need to iron them or anything.
No,
They're
it's just self-adhesive.
Sure. And then
This
etch.
was- Yeah, and then etch them all. These, I mean, this was back in, before the days of, a lot of the stuff now I use on Easy PC.
So with those ones, did you order those or did you make those?
I made them. I copied them off the magazine.
Ah, and what was the process of putting them onto the sticky stuff?
Well, they're just sticky. Each pad is sticky.
So did you scan it?
No, and the
Oh,
tracks, the tape is sticky.
okay.
Tape comes on a roll.
Yeah.
Put the pads on. Basically, photocopy the magazine thing
Yeah.
and do it one for one. It took a long time. Like this.
Gosh.
Each all of the numbers and things on there, those are Letraset, which were all individual.
Is that all Letraset?
Yeah, all Letraset.
That's very cool.
All by hand.
Well, you wouldn't notice unless you
But,
said.
this is about 40 years old.
Yeah. Look at how in line it all is.
Yeah.
Look, how long do you reckon that took to Letraset?
Considerably longer than going into a music shop and buying a Behringer mixer.
Oh yeah,
yeah,
for sure.
Yeah, a long time.
A mixer from the plans of Electronic and Music Maker magazine. He said he didn't know what to do with it because some of the wiring needs a little bit of adjustment. So it's a little bit wrong, but it's fine. We can put up with it at the museum. Funky MIDI cable, MIDI keyboard. The DIY synthesizer. No time like that to do. Right, let's get back downstairs. Oh, where's the exit? Where's the front exit?
It was at this point the problem came back with a vengeance. Yeah, whatever was wrong was getting worse.
Not battery! It's very hard to test right now. Gotta try and nurse at home.
It was a problem that had zero correlation with anything I could find. Come rain or shine, it was doing it. So I've put some electrical tape over some of the wiring there, you'll see. I've taken everything to pieces. I made sure the distributor was clean and dry. I'd looked at all of the ignition. I looked at all of the carburetor and the fuel. And yeah, it works and then it doesn't work. It was really annoying. Whether it was on load or not on load, it wouldn't make a difference. I couldn't find a pattern in it whatsoever. I stopped at so many service stations. I managed to do a couple of the other repair jobs on the road, like this indicator lens right here. And yeah, we get up to the M25 and this is when we were in traffic, and I figured out how to nurse the issue. I took it out of gear and kind of revved it and it sort of cleared up, but then at one point in the traffic it just decided to completely give up.
Oh dear. On the way to Clackett Lane services on the M25. Luckily in a safe bit of hardship. Oh, piss.
The traffic was still slow moving because it was a traffic jam still, so it gave me a couple of minutes to kind of try one last ditch attempt to see if I could find anything obvious, but it was at this point it just wasn't starting.
I'm an hour away from home. I think the smart thing is to get a recovery truck, which is pretty annoying, and figure out what the problem is at home. And there we go. Time to just give up. Poor thing. It'll be so annoying because I bet the problem is so simple. Might even be obvious to some people, but I've been running through everything, and honestly, I just need to take it to pieces. What a shame, eh? What a shame.
There were no more traffic jams now, and the speed has gone back up on the motorway. I went behind one of these sound fences, sat down for an hour and a half, and edited this video whilst I was waiting for the recovery truck.
Here it is, after a couple of days. Oh yes. It's looking very nice in the daylight. It has survived, beautiful. The same cannot be said for the car. However, I've shot a video on the Look Mum No Engine channel about diagnosing what the fudge was going wrong with this, and it wasn't as straightforward as you think. Well, for me anyway. Anyway, let's get this back. Okay, so today we're going to have a look at it straight out of the back of the car. There is a little bit of a background noise, but hopefully this is down to misunderstanding of how it's working. So we've got all of these selection switches, which make it all cross-modulatable. So we've got problems, we've got something constantly playing, and also some of the knobs aren't working. Even when we were looking at it over at Bill's place, it wasn't doing that. So what we're going to do is we're going to take off the back, which will give us an opportunity to have a little peek at what's going on anyway, and see what's fallen off. I think that might be the only two wires. Oh, it's hinged. Very fancy. Okay, so, oh my giddy aunts. Okay, this is interesting. This is going to take a little bit of figuring out. I'm sure Bill knows exactly where everything's going, but for me, it's not super obvious, but... Okay, so on the outset, it can be misconstrued as a lot of cables going all over the place, but luckily it's a DIY synthesizer of the 1980s. What cannot be figured out? So to the untrained eye, this may look like a bit of a confusing kind of kerfuffle of wires and whatnots. But luckily, if you know anything about 1980s DIY synthesizers, you'll have a reasonable idea of what the fudge is going on, sort of. So the synth voice is hiding underneath here, and then this on top of it, I think is some of the selector parts for the synth voice, maybe the controller board. I cannot remember exactly the details of the synth voice, but luckily that's when the magazines come in. Yes, that's right, we've got the Electronics Today International 1980. This is when the Digisound 80 project began. This is the first copy of it, this is the first issue. And if we flick through, we should be able to find, carefully, looking through to the next parts, we should be able to find the copy, the issue that is covering the synth voice. I'm covering all of these in the Digisound 80 video, which is linked below in the DIY synthesizer history playlist. But we'll get a good idea. We'll get up to July. I don't think we're there yet. We've got a good old ways to go. Might not even be in this one. So flicking through, obviously there's all of the adverts that we've already looked at in other videos, like on the Powertran Transcendent Polysynth and the Powertran Transcendent 2000. And all of these Cricklewood Electronics, look at all of these. You can get yourself a 2N4222 for 97 pence. June 1984, this is quite interesting because you've got the digital delay line. On the June 1984, we've got things talking about the Microtan, which is right here, which is what was used in the Alpha DAC, which is the polyphonic version that Bill was talking about when he was building that. He said he couldn't get the Microtan to work with it, which is a computer of the time. So I don't think the synth voice was covered in the Electronics Today International. I think it's when the Digisound 80s projects jumped over to Electronic and Music Maker, and this is upside down. July 1981. In fact, here is a Digisound project right here, the Alpha DAC Synthesizer controller. What a beauty. That's the polyphonic module for it. Very interesting. Let's see if we can find the synth voice in here. What do you reckon, Rick? So we need to actually go quite a way along to get to the synth voice issue. I think it is actually in 1985. So we're jumping past all of these funky folk. And so no, we're at the end. Where is 1985? Annoyingly, I don't have that copy. But if you can see from these screenshots of the 1985 one, because I've only got it up to 1984. So yeah, look into the back of this board right here. We have... This is the synth card. This is the Digisound synth voice, the Digisound C9 that was in the February-March 1985 issue. You'll see that there's some interesting circuitry going on, but mainly Curtis chips, etc, etc. The Digisound 80 voice card that this synthesizer is based on came in 1985. There's a link below to the scans that I'm overlaying right now. With the actual Digisound 80 that we got a couple of years ago from Gordon that built it, there was actually with it a unfinished version of the synth voice. This is what the actual synth voice looks like in the project design. So this is the same circuit board. I still need to wire it in. That'll be maybe that's one that's an upcoming video actually to actually build it as it's designed. Also, what came with this was a couple more of the synth voices because Gordon, I think, stopped at the point he was building the Digisound 80. He was going to do much like Bill did. What he was talking about is make the polyphonic version with 4 synth voices. The inherent issue with the 4-voice polyphonic version is each of the voices are separately tuned, and it's a bit of a behemoth to try and keep in tune. And it's very similar in design to the Powertran Polysynth, which yes, is a bit of a behemoth to keep in tune. It's not impossible, but it's still a little bit of work. This is the Alpha DAC controller that is at the museum with the Digisound 80 that came from Gordon. This is a project. He had 2 cards on this. It's a very interesting beast. So what Bill was talking about in his interview was one of these and then 4 of the synth voice panels connected together. He didn't have any photos when I asked because it's the 1980s and iPhones don't exist. So this is the digital oscillator, the voltage controlled digital oscillator. It's got wavetables, but they are on the EEPROM. Now, the voltage-controlled digital oscillator also came out at the same year as the synth voice, which is 1985. If you think about it, it's quite a way along because the Digisound 80 was introduced at the start of 1980, so that's a whole 5 years of this project. Anyway, the VCDO, voltage-controlled digital oscillator, is, as mentioned, based on an EEPROM. The EEPROM is basically a chip that you can program with a load of 1s and 0s, and you could get to each of these single 1s and 0s inside this chip via the address pins, going, yes, please, please. The VCDO is controlled by the Curtis 3340, which is actually the chip that is the voltage-controlled oscillators in all of the other Digisound projects. However, in this instance, it's driving in radio frequencies really high to be able to flick through all of the 1s and 0s in the EEPROM and then turn those 1s and 0s from the EEPROM via a digital to analog converter from the digital 1s and 0s to an analog signal. In doing this, it actually creates a digital waveform based on a wavetable inside of the EEPROM. This is a very similar thinking to the Oscar of a relatively similar time frame. And whilst the EEPROM for this project actually had programmed waveforms, it does say in the magazine that you could put whatever EEPROM in it and it will just read the data that is on the EEPROM, whether it is just text data or a random game or something, and it will turn that into a wavetable. You will also notice that Bill put a screen on it when the actual original one is just LEDs going up and down. So somewhere in the jumble of wires and circuit boards is a 7-segment converter to be able to drive the screen from those LED signals that would have been sent out from the circuit board. Very interesting stuff. So it's a wavetable oscillator over here. And then there is also a analog synthesizer here. And then you've got a power supply here. LM324N, that could be a headphone amplifier equally. There's a circuit sitting here. And because these are single pole switches, these are basically turning on the lights for the switches to show you that they're switched. So there is a few functional anomalies on the front panel. And yeah, what I need to do is wiggle my fingers around and see if there's anything connecting weirdly. The first issue I have is the low frequency oscillator is constantly on. That means that this isn't connected to ground. So look in here. ground is, oh my gosh, this purple wire is connecting to this pink wire. Then this pink wire is connecting over here. So yeah, there's a couple of issues, but I'm hoping that the issues are basically boiling down to the ground not being fully connected. Now, to save having to track down the exact broken cable, because it might take me a while to find the connection, I'm just going to literally make a new connection from what I know is ground. So onto their chocker block strip. I'm just plugging in the connection of the power to the keyboard controller. Strangely enough, there is a note that is coming through that is only happening when this is connected, and that is wired over to this down here. So this power seems to go over to this section here, which is the keyboard controller, the Digisound 80 keyboard controller module, but bolted here. And we've also got this, which I think is the Maplin spring reverb driver. That's connected to the spring reverb here. Really cool, but there is one thing that he said, that background noise is actually why he added this switch right here. So the switch basically turns off the screen, and the screen seems to make that noise. I've got a slight theory that I want to test. Basically, it's wired in such a way that there's a single power cable basically powering the keyboard controller that's got this LED setup on it, and also the spring reverb driver, which is right here, which is actually also the output of the whole module. I think because it's such a long cable going to power this and this together, maybe the demands of this are making it a sound in here. So what I'm going to do is I'm going to remove this power cable that is connecting this one to the synth. I'm actually going to give this its own wire to the synth. I've quickly got this wire tacked in, so it's actually plugged into the power of this one. So these two are now separate. Let's quickly turn it on. Yeah, that sorted it. Now on first glance, I know it looks a little bit like a Mini Moog, and that is like what Bill said. It was designed to look a little bit like a Mini Moog. Well, a lot like a Mini Moog. It's very similar. It's got the same kind of shape to it. The controls are sort of in style of the Mini Moog, but not massively, but enough. We've got this line here, which is a couple of low frequency oscillators. We've got this, which I'm not 100% sure what is actually doing. We'll figure it out. We've got the voltage controlled digital oscillator, which is a Digisound 80 module. And then we've got the VCO1, VCO2, the voltage controlled filter, and also both of the envelopes from the Digisound synth voice. And then we've got the output, which has also got a spring reverb mix. Then we have all of these switches that seemingly do different things. And I've already played on it a little bit, and I've got to tell you now, it doesn't sound anything like any other Curtis chip synthesizer. I think it possibly is down to the gain staging. It's a very saturated synth, but you'll find out soon. It doesn't fully function like a classic synth that you would expect. It's quite quirky, but that's down to the design of it. And, you know, we've got to keep it like that. The filter sounds pretty wacky. These switches are for routing of the internal patch cables. So if we flick on envelope plus, which is below the voltage control filter, I'm assuming that is going to mean that this envelope controls this. So got a very funky sound to it. It doesn't want to stay exactly straight, which is quite interesting. It's got some expression controls down here, which seem to be controlled by the LFO up here. So, and we've also got a glide that can be momentary. Reverb all the way. now we've got the Wavetable oscillator. Let's turn off the reverb so we can just hear the oscillator as well as we can anyway. This is flicking through the different wave banks on that EEPROM that is sat on the voltage controlled digital oscillator PCB that is right there. Funnily enough, in the magazine it actually states that if you put any EEPROM into that, it will read the data on that chip as a waveform. Whatever it is, it could be a game and it will turn it into a waveform. But this is the actual EEPROM that is written for the magazine, so it's got different waveforms that are sort of related to each other in different banks. So we've got 4 different banks. There are some modified modules of the VCDO in the Digisound 80 thing where this is selectable via a gate in, so you can sync that up. Let's turn down the voltage controlled digital oscillator and jump over to the Digisound Synth voice. This is already still going through that output, so it's already very saturated. More than it should be, but it's one of the design choices. We got noise. These controls are for the pulse width modulation, so if we flick that, I'm assuming. We're gonna get also, you can have it controlling the frequency as well. An exponential mod. There are some things that can be seen as a little confusing, but that's just down to the design of these things. It's not really designed to be, you know, universally understood. So it's laid out in a very interesting way that I think is pretty damn cool, to be honest. This is sounding a little bit more like a standard synthesizer now. Turn up the resonance. Now we're going to bring up the second oscillator. We're going to turn up the modulation on this, which is carried by the VCDO, I think. Now we've got sync mode. Get some funky ones. go to crazy town with the VCDO in it as well. It's a very saturated synthesizer, but I don't mind that. It sounds like its own thing, which is pretty cool, I think. It's got definitely a pretty raw sound. Turn on the glide. Robot train. Amazing. All in all, it's a very interesting take on a Curtis chip synthesizer. It doesn't sound like other Curtis chip synths, and that's, I think, down to somewhere in it, the gain staging makes it sound like a bit saturated. Bill did mention that he was a guitarist primarily, and he actually had a couple of DIY guitars there. It sounds a lot more slammed and fuzzy and saturated on the output of the synth, which makes it sound in itself quite unique. And I can empathise also, coming from a guitar background, that is quite a nice pleasing tone. I know it's not a tone that is up everybody's street. Some people like the nice soft like, but for me there's nothing quite like a nice saturated slammed tone, and that's what this thing has in droves. Yes, that one right there. Moog inspired Digisound 80 project that can be seen as a Wavetable DIY synthesizer, a DIY Oscar, something like that. It was very interesting to talk to Bill. I hope you enjoyed the interview that we had with him, and thank you very much, Bill, for this. This is going into this museum's not obsolete now, so this will be next to all of the other DIY synthesizers that we have in our collection. You can come and play on pretty much all of it on Saturdays and Sundays in the afternoons. A link to the information on the museum is below, so come along and have a look at this. If you want to help support the museum, then go and check out over on Patreon, which is below as well, because that supports keeping the roof over all of it. And over on Patreon, I've included a bunch of the direct WAVs that you can use as samples on this, and also made a few sampler instruments of this that can be played like a VST. So if you want to play this on your own computer, iPad, or anything like that, then there are some decent sampler instruments available to download over there, as well as a bunch of others from past videos and projects. But anyway, until next time, I'm Sam, look mum no computer. This is the Mini Digi. If you like what you see, don't forget to subscribe and don't be scared to try it. Doodle-doo.